Hello everyone, my name is Augusto and today I'm going to be talking about linear functions. So here's a quick outline of the section. First, I'm going to talk about how linear functions are used in the business world. Then later I'm going to give you some initial concepts regarding linear functions, then how to determine the function and information about its graphic, and also some important facts that you need to keep in mind regarding this type of function. So linear functions are extremely used in the business and management situations where they are commonly used to explain trends or explain evolution, let's say, of a variable in function of another. So example would be production as a function of employees. And regarding the initial concepts, it's important to keep in mind that the formula for the linear functions is f of x is equal a times x plus b. So as you can see here, I have like two terms, and it's important to keep in mind that both a and b are real numbers and that x is also inside of the real numbers. And regarding the a, it is called the slope, and b is the constant. So let's say, for example, we have like this function, and it's important to just realize like this would be the a2 over 3, and minus 5, it's important to keep the sign, would be the constant. Regarding function determination, it's an easy concept. Every time that is like you see determine this function, the meaning is really what are the value that the function has for a specific value of x. So basically, what would be f of x? So let's see, for example, a simple example would be this function f of x is equal to 3x plus 1. So if you, let's say, if I want the determination of the function when x would be minus 2, so basically just plug minus 2 into the function, so have like 3 times minus 2, that would be minus 6, plus 1, that would be minus 5. Okay, and now regarding the graphic of a linear function, it's really important to keep in mind that it's always a straight line. And an easy way to find the graphic would be, if you already have the function, would be just to plug like some values for x. So let's choose, I don't know, like easy values for x, so then you can see the graphic. So basically, let's say when in this case of the function, when x is 1, we're gonna have like 2 times that 1, that would be 2 minus 1, y would be 1. So we want to have like this point, and let's choose another value for x, let's say minus 1. So when x is minus 1, it's going to be 2 times minus 1 minus 1, that would be minus 3. So we have like this point over here. So then you just like the first point here and the second point here, and then you guys can see that we could have like a straight line over here. Regarding the slope, we also have a formula that we can use to calculate it. So, and that would be like the variation in y over the variation in x. And if you continue to develop this equation, it's going to be extremely useful, because over this equation you can find the initial linear equation that I showed you guys a couple of slides ago. So basically that would be the idea. We're gonna have like y2 minus y1 over x2 minus x1, that would be equal to a. And if we continue to develop, we're gonna have like this formula over here, that is, sorry I don't have like any space, but just you guys can kind of have an idea that this is multiplying this. So we go back to the initial formula that we have, because here we have like y a times x, and later we're gonna have like the b. And it's also important to keep in mind that regarding the slope, if it is positive, bigger than 0, then you already know that the linear graphic is like increasing, so you already know it's gonna be like that. And when it's negative, you also can know that it's gonna be like decreasing, so it would be something around this. And also regarding slopes, it's important like to keep in mind when you have like parallel lines, that every time that you have parallel lines, like they have the same slope. So let's say you have like this over here and this over here, so you can say that the slope in one is equal to the slope in the second line. And every time I have like a perpendicular line that is with a 90 degree, so you can say that the first one, you can use this formula over here, that is 1 over the slope of the second one. Okay, and regarding the b, when it comes to a graph, it's basically like the y-intercept. So let's say you have at this point here, let's say this is 2, and the graphic's over here, so we can assume that b in this case is 2, so it's always the y-intercept. Okay, some important information to keep in mind is that every time that we have a vertical line, it is not a function, because every time you have a vertical line, it's like, to be a function, we need one output for each input. And over here, like an example, you can see here that if you have like, let's say this one, this would be not true, so it's not a function. And regarding horizontal lines, so you have these and right here, so it's important to realize that the slope in this case would be 0, because the variation would be 0. And regarding the domain and the range of this function, we can say that they all are inside the real numbers.